Yes, so thank you very much also for the kind invitation. It's a great pleasure to be here, and let me tell you a bit how machine learning is pervading retail and many other sectors. So first a bit about us. Who is Blue Yonder? Originally we come from CERN, and then Blue Yonder started as a spin-off from the University of Karlsruhe. Since about 2011 we focus on the retail sector and also endeavored a bit into industry, but mainly focus on retail. And since a while now, we try to get bigger, of course, but most of all, we try to move into predictive applications, i.e. how you wrap up machine learning in the business environment. So for those of you who haven't been at CERN, this is how it looks like, nice scenery, and this is how it looks like 100 meters underground, where thousands of people work on like the biggest data there is. I skipped the company history, and of course we're all proud of our ads, not just because we like awards, not just because we like to win awards, but also it tells us we're doing something relevant and something right. But let's dive into it. So the key to becoming a better company is to make better decisions, obviously, and the key to make better decisions is use the data you have. Back in 2012, it was all sort of easy, if you want to know. If you wanted to enter the big data world, you had a few companies to choose from and a few technologies and everything, but now we have 2016, right? So you can see the world has grown more complex. And it's also moving away from just talking about infrastructure. Of course it's still there, but also what you have is applications. What do you do with all the infrastructure and machine learning if you want to enter the business world? So what is data science, at least from our perspective? Of course, you have all these sort of more technical aspects of data storage, extracting data, data access. Also that is not trivial because you don't start on a green field. You have existing data warehouses and things in the real world, and you need to access them, and this is a non-trivial question for many. You need to deal with data quality, statistics, and increasingly causality become more and more important. Of course you have machine learning, but most important, you have business development if you want to bring machine learning to a business setting. So let's think about this for a little bit. What does business development in this context mean? Start with the vision, right? Where do you want to be? Right? This is not a case for technical people as such, right? Of course, you need the input from data scientists and technical people to be able to judge what you can do realistically in a given amount of time. But this is really a management question. If you want to bring machine learning to business, you have to involve all the management levels and say, what do you actually want to do? What do you want to solve? Where do you want to see yourself in 1, 2, 3, 4, 5 years in the future, right? And try to forget existing processes, existing constraints in your company. If you do this exercise, really start with where do I want to see my company in like 5 years? Or something like, and then you can fill in all the details later and say, okay, I have these constraints, I have these constraints, this I cannot change, this I cannot change, I want to change this, and so on. This is really a strategic and management kind of decision. And then you can start with the fundamental layout of bringing machine learning to your business. What do you want to do and why do you want to do it? Where is, for example, your current pain point and where do you want to improve? And also, where is a new opportunity and what do you want to gain from it? Right? Again, this is a management type of questions. Once you have this and you can address all the more technical questions, do I actually have data? Yes or no? If no, you need to generate new data. What's about the data quality and so on? And define what we call the target. What does the machine actually have to predict? Also, this may sound trivial at first, but you have to see it in the business context. And what is it actually what the machine should generate a number for, and what happens with the number afterwards? Right? What is the process which brings you from a prediction to the actual decision or the action which happens depending on the prediction from the machine? And of course, this is a machine learning conference, so I won't spend too much time for this. In your machine data science project, your machine learning project, you have to deal with all sorts of variables. Right? You have to deal with discrete, semi-discrete, continuous variables, and so on. But let me just highlight missing values as it comes up ever so often, and it's a very important ingredient. Right? Beware that you don't just fill up those numbers, or you discard elements which have missing values, or you don't just impute missing values either, because in the patterns of missing values, there's also information contained on that. So you have to treat that separately from all the other variables or from all the other cases where you have information. For example, think about a sensor, right? A sensor fails in a specific environment. So when there is non-usable information from that sensor, that also tells you something in the data. So you can't just throw it away and you can't just impute it. Right. Then you do machine learning, but I won't focus on the machine learning step too much. Then you do a prediction. I'll come to this in a second. But the prediction as such doesn't help you either, right? You need to embed it now into your business. So you need a decision. What happens in a business setting? Or, what do I do? What do I act upon the prediction? And as we've seen before, the output of the machine learning, if you do a regression type of analysis, is not just a single number, right? Think a supermarket. How many apples will be sold tomorrow, right? The output is not like 5 apples. It should be a complete probability density distribution. And only if you have this information, you can optimize and say, okay, I want to take, for example, a service level of 95% availability and optimize on that, right? If you only have a single number and say 5 apples are going to be sold, and you don't have an optimizing handle on this, right? Then you have to use the numbers that there are. If you have the complete event, then you can optimize in terms of KPIs, in terms of availability, and in terms of service level towards your customer. It's also very important that you have this on an event-by-event basis. Even if the overall distribution of, for example, the sale of apples looks nice and smooth and Gaussian and everything, the individual event is influenced by many things, like the day of the week, or the weather, or the size of the store, or where the store is located, and what time of the day it is, and so on and so forth. And only if you ingrain all this information, the individual probability distribution can be very much different from the overall one. But in the end, as a business, you don't really care about these details either, right? They're very important to come to a decision and an action, but what you want to do in the daily business setting is data flows out into what we call a predictive application, which sort of ingrains everything from the machine learning model and the decision-making process, and you bring the decision back, and you still have a controller, but this controller is sort of monitoring and acting upon events which you sort of can't foresee, like, I don't know, a thunderstorm or maybe a tornado passing through, and obviously that is going to disrupt your business, but you can't really predict that, right? On these events, you really need to act manually, but in all the other cases, you want to have the machine decide and implement the action, and you are there as a monitor and sort of see if the right thing is going to be done. So you want to have a complete flow of data into the predictive applications and decisions and actions back. Right. So as our founder said, decisions beat insights any time, right? It's great if you can derive insights from your data, but what's important is what do you do with these insights, right? And if you have like a few decisions to be made per day, like someone told me, what about all this automation? We do with our expertise and said, okay, how many decisions do you have to do in your team today? Let's say like 10. It's okay, fine. Now think about you have 600 decisions to make in 3 hours. And this you can't do, right? You have to sort of delegate this into to a predictive application, and you have to design the application such that it meets your business strategy. So I'll walk you through a few examples where these predictive applications successfully go into the retail sector. Let's start with the supply chain first. Right, replenishment, right? Think supermarket. How many apples do I need in a given store on a given day? And if you can sort of balance this on-shelf availability versus how many apples do I have to throw away? Right? Most of the food, for example, is perishable, at least in one way or another. Like fresh fruit has a shelf life of maybe a few days. Some meat has a shelf life of 1 day, 2 tin cans for a few weeks and months even, right? But if you can optimize this, it really helps everyone. Right? From an environmental aspect, it's good because about 12% of all perishable food are thrown away. In Germany, that's about 20 million tons of food every year, which has to be thrown out of the supermarket. So if you can reduce this, right, you help the environment because you don't throw away food. You also help your environment because you don't have to transport it everywhere. And you help the supermarket because you don't have to buy it, stock it, and throw it away. And you also help the consumers because you keep the same service level. So how do you do this, right? What comes out of the prediction is this kind of probability density distribution which I showed you earlier, right? So now you need to decide as a business, in the extreme case on a product by product basis, which kind of service you would like to offer to your customers, right? If you, for example, think, I'm going to order like 5 of this product, let's stick with apples, right? Then you know that you are running out of stock very often, because the main bulk of the demand is going to be higher than 5. On the other hand, you have low stock and you have low waste because you have so few on your shelf. Maybe this makes sense because this particular product is not your signature product, or you don't really care about it in your daily business. On the other hand, your signature product, for example, you would say, I would like to have a high availability, even knowing that the bulk of the demand is lower than this, right? Then you don't run out of stock because this is a service level you would like to promise to your customer, like have 99% availability of this product. But then you have to take into account that if you have so much on stock, like first of all, you have the capital cost of keeping it on stock, but also you have to throw away in case of perishable food, right? So you have to balance these two sort of contradictory KPIs, if you want. You have to decide for your use case and for your customers which is the best balance for you. And what you can do with this kind of simulation is take those two KPIs, again the supermarket example with the apples, for example, perishable food write-off rate versus out-of-stock rate, and ideally, of course, you want to be here at 0,0, but the simulation tells you can't do that. The simulation tells you I can only be on that blue line. And now it's back to the management, right? And this is the important step. Before, you would say, okay, our specialists, our experts, our supply chain experts would do the whole thing, and we as a manager would sort of supervise or something. But now they bounce the question back to us and they say, this is the curve, and now you have to decide where do you want to be. Right? You can only achieve the write-off rate here and the lowest out-of-stock rate here. Now you have to decide what's more important to you, out-of-stock versus write-off. And you can pick any number here, but you can't pick any number which is not on the blue line. And this is a management decision, again, which you can implement in a predictive application, but you have to sort of give back the power to make this decision to management. Right? And this is, if you then do this, this is, for example, a result from one of our customers. Right? Before you switch to a predictive application, you have an overall out-of-stock rate, and then once you made your optimization strategy, you can see sort of when this happened, and then you sort of wiggle about the 1% out-of-stock line, because this is the strategy they would like to drive for this particular product or product range. One of our customer statement here, just to illustrate that they're really getting a lot of benefit from using these predictive applications in their day-to-day business. Another application also in the retail sector is pricing. Of course, we have to pay a price for any good or service we would like to use. So what is the best price? There are many conventional pricing strategies, market penetration, margin orientated and so on. But what really is the best price in a dynamic involving market? And again, this is something you can tackle with machine learning. So let's start simple and say, okay, you have a price and demand curve. So let's say this is your demand. What's the best price for this product, right? Well, you can overlay your revenue curve, and then you add the cost. What does it cost you to produce or to stock this product? Does this answer your question? What is the best price? Maybe you're more interested in the profit. Still, now you have all these curves on top. But again, this doesn't address the question, what is the best price, right? Now it's back to the management again, right? Predictive applications can help you implement the strategy, but the strategy has to come from the management again, right? What do you want to do? Maximize the demand? Obviously, right? If you go back to the previous curve, if you want to maximize demand, the best price is 0. If you want to maximize revenue, let's go back. If you want to maximize revenue here, then you are somewhere here. If you want to minimize cost or maximize profit, and again, you have different prices, right? So for all of these choices, and they're all viable strategies, for all of them, you can have a different price. Now, what is the correct price for your product? And this, again, you have to decide in your business model, right? Or, I mean, you don't have to stay with one strategy, right? You can say, okay, I want mainly revenue, I want both revenue and profit, mostly profit, or I want to optimize profit only. And as you can see, the prices are similar, but they're not quite the same. And again, this is a business strategy and a strategic decision you have to make. And the predictive application then implements this and adapts to the market. And you can see here's quite a bit of a variety between those prices. And what machine learning then does is measure the response from the market as you go, and demand also changes with time. So you put all of this into the machine learning, but the machine learning then sticks to the strategy and says, I want to be, for example, mainly profit-orientated or 100% profit-orientated, and then calculates what is the best price according to your strategy given the current situation in the market. Again, a nice customer statement. And the last example I'd like to show you is this customer targeting. For example, we all have to live with advertisement, but think like of a catalog someone sends you. Right? What do you do with it? Do you act on it? Do you not act on it? This is what you do as a customer. But for the company, the question is, who do I send the catalog to, for example, or who do I give an incentive, like a coupon? Who will react to this? So this is what we call customer targeting. And what you traditionally do is this sort of rule-based. You have your customers and put them in little boxes, and you have your expert group doing that, or you can even do it data-driven, right? Based on the data you have from your previous customer shopping behavior, you put them into boxes and devise then rules and so on, and then try to infer who you send a catalog to. But if you do that, this usually leads to something like this. So for example, say we send a catalog to half of the customers we have, as identified by our expert group in the company or something else, or by the rules. And then you say, okay, in our evaluation periods, 30% of those who received the catalog will buy something. 6% of these customers will not buy something. So now you infer, and if I sort of linearly infer, like I should send more catalogs, and there's a large effect between sending out a catalog and buying something and not buying something. Right? Remember here, these are the two groups, those who got a catalog bought and those who didn't get a catalog bought as well. So you think there's a huge effect. But what happens in reality is that there is no such huge effect. And if you send more catalogs, this big effect sort of vanishes, and you only have a small effect. But why? I mean, you measured it from the data. You did a test. You have your rules. You put it to the data. You measured the response from the data. But why does it not happen as you think it did? This is because correlations, for example, are not alone. Right? The important thing here is that there's a causal relationship in the data. Correlations are not the same. Just to illustrate this point, you can make arbitrary correlations of data. That doesn't mean that, for example, the divorce rate in Maine has a causal implication to the consumption of margarine. The important thing here is that you have historic data on your customer. This is what you use in your rules as well. You have your target, right? Those who you sent a catalog to should buy something. And here's your action, send a catalog. But you're not really interested in the correlation between all of those, but you're interested in the causal relationship that who do I send a catalog to? And because I sent a catalog, they will act on this incentive. This is what you want to measure. And if you work with correlations alone, you're mainly stuck with those. And of course, you have a high correlation there, but you really want to filter out who act on your incentives. And this leads you to causality-based targeting, which is something quite new, which we do in our machine learning approach. And we have the first projects live, how to ingrain causality into machine learning algorithms, right? Because you want to only target those persuadables, not those who sort of say, a catalog from them, I'm never going to buy from those. Or lost causes, they will never buy from you anyway. Or those who will buy anyway, right? Those guys, you don't need to send a catalog to because they will buy anyway. And those you don't need to send a catalog to either because they will never ever buy. But you want to send a catalog only to those few who will act upon because they got an incentive for you. right? And there's a first project is live with that as well, and looks very, very promising. So thank you very much for your attention.